I imagine that with my absence yesterday, my not being able to help you yesterday, and then also the fact that in algebra today, we didn't have any time to do the practice, let alone finish the lesson. I imagine that a lot of you will be busy today. Like I really shouldn't see anyone because I don't think anyone is completely done with everything, but we'll see. Um, if I see you doing other things like playing games, whatever, then I can check and see, do you have all your missing stuff done, including like the task from today. So today the task is on the screen. Hang on one second. All right, but I didn't even have time today to take everyone through the slides and the learning targets. So there are two separate practices. I try not to make them long, so try to make them each around 5 or 7 questions, something like that. And ideally, I want you to practice with the elimination method, not with the others, although you might be able to use the others to check your answers. Know that not all the questions will say, what's the answer? Like, where do they intersect? They might be different on your test. It'll say like, what's the incorrect step? What's the first step they need to do if they want to solve by elimination and all of that stuff. So here are the learning targets. Today, we investigated how adding and subtracting equations can help us solve systems of linear equations. So you can only, at least right now, tomorrow you'll see how adding this other stuff gets you to be able to eliminate. But right now you can only do elimination if they have what in common? A coefficient in front of the same variable. Good. So that could be, I'm just gonna make up numbers, they may or may not work out nicely. But that could be something like this. All right, which one has the common coefficient, the x or the y? The x, and while they're opposites, that's fine, we still consider them common. That just means that in order to solve this system, would I add or subtract to eliminate? You would add, that's what would make this go away, and then whatever you do to make it eliminate, you have to now do to the rest. So then it's 2y plus negative y is what? 1y. What's 7 plus 10? And then that gets you the answer for one of the parts of your ordered pair. To get the other part, what do you do from there? You plug in y into one of your original equations. It doesn't matter which one for elimination. I think for substitution, it does matter. But whichever one you think is easier to solve, which one do you think? I agree. When I plug it into the bottom one, it'll look something like this. Start isolating the x or the other variable, whatever one ended up being the one you have to solve for. It can sometimes be the y. And look, this worked out nicely and I just made it up. What's opposite of multiplying by 3? And then my x ends up being 9. It's 27 divided by 3. As an ordered pair, how would it be written? Good, 9, 17, because it always goes x and then y, even if you solve for y first, like we did in this one. That's how you write your final answer. And that's how you can check in Desmos, probably is the fastest. That's how you can check that you've got the right answer, but knowing the algebra is still important. Like I can't stress that enough to you. Your questions on your test aren't always just gonna ask for the final answer. It'll ask for like steps along the way. So there's that. I tried to show you one of each kind. One where you have to add to eliminate. I tried showing you one where you need to subtract. And then my first hour didn't get to this part, but you need to know the special circumstances. So if you already saw this part, you probably don't need to write it down, but my first hour definitely did not. But on the second page of the notes, there was a space for special circumstances, and here they are. If you are starting to solve by elimination, so notice, and it's weirdly blurry, but notice you have common coefficients in front of the x or and the y. When that happens, it's up to you. Pick which one you want to eliminate. So say I want to eliminate the x, and I decide adding will eliminate it. Well, when I continue, I see that adding also ends up eliminating the y. So both variables eliminate. You still have to continue, like you still have to add this side and see, does it give me something that's true? Does 0 equal 0? So when it gives me something that's true, what does that mean for my solution? Infinitely many. That means that, and I think it, I don't know how to say it, but that means that there's more than one combination of x and y that'll make it true. Okay, so that what's true is infinitely many. When it gives you something that's not true, so like in this situation, we had to subtract to eliminate, and you could have picked either one, they both have common coefficients. But we have to subtract to eliminate, say like the x, so we have to keep subtracting in the others. It ends up eliminating both variables, but you still have to continue to see, does it give me something that is true or false? You still have to do -2 minus 4, I get -6. Does 0 equal -6? No, and when it gives you something that doesn't make sense, that makes no sense, that is no solution in that case. All right, so makes sense, infinitely many. Doesn't make sense, no solution. Any other one where you do get values for x and y, that's one solution, and the solution is that word here. Okay, so I'm gonna leave that up, but I'm sure a lot of you are not done with everything, so again, I shouldn't see a lot of slacking today. I wanna get this time wisely, so that way you don't have homework at home. And that way you're ready for the unit test, which we are taking Wednesday next week. If you are an overachiever and you are done with everything, the study guide is right at the top of Schoology, you can't miss it. What else? I do have the paper practice tests printed now for the constructed response portion, like you can start preparing for that. Yeah, anyone? If you have questions as you go, let me know, but, I'll check in probably last 25 minutes to see if you have requests for that you want to. Okay. Yeah. We are on number 2 of lesson 15, part 2. I know, sorry, long title. But it says select all equations that share a solution with this system of equations. And since we are in the elimination lesson, I am gonna solve it with that method. But I like really, if you were taking a test and you wanted to just do whatever one was fastest, like the fastest method, then I probably would say, yeah, Desmos is probably a good bet. But first we need to find the solution to this system. So, and I see why you might be struggling because this isn't set up to where we can use elimination right away. Tomorrow I will teach you how to set it up, but we're not there yet. So then let's see if there's a different way. With this one, the way it's set up, I would just go into Desmos for that one. So first you want to find what the solution is to the system. And by graphing, I don't have to put it in any special form if I'm using Desmos. That's the nice thing about it, but you still have to know all the other things I've taught you. The solution for the system is a weird decimal. So let me just kind of write the gist of what it is. Okay, so that's my solution to the system. The rest of these are only like single equations, but if they have the same solution, then they would also intersect at this point, meaning that they also have this matching coordinate. So we're just going to type them in, and if they do share it, then I'll select it. But we do have to check them all. So 5x plus 4y equals 2x minus 7y. If you can't tell, it does not intersect at that coordinate, so we're not going to pick that one. Let me try the next one. 3x minus 11y equals -2. I don't even see it anywhere near here, so don't pick that one. 3x plus 11y equals -2. That one does intersect, and you can zoom in to really make sure. So I'm gonna select that one. So yeah, this one unfortunately doesn't follow what I showed you today, but knowing what you know and knowing that if they share a solution, they'll intersect at the same spot is what will help you with this one. And so only these two share the same solution as the system. All right, does that make sense? Okay. Other questions from any practice? Amy? Okay. You said number 5? Okay. So now on the part 1 of 15 practice, we have Kieran sells F full boxes and H half boxes of fruit to raise money for a band trip. He earns $5 for each full box, $2 for each half box of fruit he sells, and earns a total of $100 toward the cost of his band trip. This equation describes this relationship. Which of the following shows the equation solved for F? So when they give you the equation, that makes it easier than having to make it from scratch. All they want you to do, if they want you to solve it for F, they want the F to be alone on one side. So we're isolating F. Start with what's farther from the F. Would that be the 5 or the 2H? The 2H. And I say the 2H together because if I'm isolating the F, I would want that whole 2H to just disappear completely, not just the H. So how do I make the 2H go away? And whatever you do on one side of the equal sign. So then this will cancel. I get 5F equals 100 minus 2H. You can leave it like that. For these, it kind of looks like they have the 2H second anyway, so I'm not going to rewrite it. For me, like I'm not going to switch the order. I'm just going to rewrite it. And fully isolate the F now. What's opposite of multiplying 5? And do it to the other side. And remember that one warm up that said you have to do it from each term. So that's why I'm writing it like this. I get F equals, what's 100 divided by 5? And it's not matching what's over here, but what is 100 divided by 5? 20. And then this can be a fraction, but it's not matching what I have over here. So I'm going to kind of backtrack a bit. Instead of writing it like this, where it's under each term, I'm going to write it where it's under the entire right side, which is equivalent. Like that does mean the same thing. And the parentheses don't need to be written because it's assumed that when it's in the structure, you would solve the entire numerator before dividing. So I guess it's just knowing like what they mean, like parentheses or not. Which one best matches? But it might be shuffled on yours, so pick the one that matches exactly. It has to be 100 minus 2h because we had to subtract 2h on each side. So good on that one? All right, Keegan? Okay, so number one, lesson 15 part 1. So we have which equation is the result of adding these two equations. So this isn't trying to get you to solve by eliminating, although it is using a step from eliminating, I guess, if that makes sense. It just wants you to add these. So we're just gonna do it. They are lined up to where like the like terms are on top of each other, so you should be able to add them pretty easily. So it's negative 2x plus 3x. No. And negative 2 plus 3, because it said they want you to add these two things. Okay, 1, good, so it's a positive x. What's 4y plus negative 10y? No, 4 plus negative 10y. Okay, good, negative 6y. And then 17 plus negative 3. 14. Okay, so then the one that matches that completely is this one. And you might be wondering, why did it make us do that? Well, because you do add equations when you're doing elimination. This one isn't necessarily making you do elimination, but I don't know, I guess you just need to know how to combine equations to make it do one. In case you were wondering, if I were to graph these, all three of them, they would all intersect at the same spot. So adding equations isn't like making a new solution or something like that. It's just making it a little easier to solve. Other questions? So we have which statement, and this is kind of like what you'll see on your unit test, by the way, that's why I say you still have to know all the methods. But it says which statement explains why 13x minus 13y equals negative 26 shares a solution with this system of equations. And they have some explanations. And they're not saying that they don't all share a solution. They're asking you why they share a solution. So since they're saying they do, then I know that they would all intersect at the same spot. But we just need to know why they're saying that. So if I were to add or subtract and make a new equation, that's still having the same solution as the ones in my system. So kind of try to see like what math I would need to do, adding or subtracting. I don't know yet. I have to figure that out. To get a 13x minus a 13y. Like, would adding these get me 13x? No, but subtracting would. So see if that works. So like 10x minus negative 3x does give me a positive 13x. Negative 3y minus a positive 10y is negative 13y. And you can use your calculator to work out the numbers, just not the letters. Just leave the letters off and make sure to reattach it when you're done. All right, and then 29 minus 55 is negative 26. So they had to subtract to make this an equivalent equation with the same solution. So they said, okay, so far that answer is looking good. I know I didn't read it out loud, but let me compare it to the others and then I'll explain. Okay, so the one that says that we subtracted is the one that is right. We did not multiply these together. We did not add these together. And then this last option is more so talking about like if I were to rearrange them in the slope-intercept form, which is not something you need to do for solving by elimination. If I were to rearrange them into slope-intercept form, that wouldn't necessarily mean they have the same slope. Like that wouldn't prove that they have the same solution. That would be like a no solution if they have the same slope, different y-intercepts. So yeah, the only one that makes sense is what we actually had to do to create this equivalent equation, which would be subtracting the two equations in our system. Questions on that one? Okay. Questions on others? Yeah. Which equation is a result of subtracting the second equation from the first? And if you remember, like when we did that translating expression, like that from is a switch word. So that means we're doing the first equation minus the second, okay? Just sign up, it was the other way around. We are doing the top one minus the bottom one. And so let's subtract that. We get 4x minus a negative 5x. What happens to that double negative? That's positive. And yeah, 4x plus 5x is, so I imagine that was probably going to end up being the answer, but if we continue, I get a negative 6y minus a positive 2y. Minus being a positive is the same as just subtracting. What's negative 6y minus 2y? Negative 8y. And again, you can use the calculator for the numbers, just not the letters. You can do the out. And 13 minus 5 is 8. So again, we're not actually solving this one fully, like I guess, for the system of equations. We're just practicing adding and subtracting them to make it equivalent equation. All right, any others? Cameron? 15 part 1, number 3, you said? Okay. So we have solved the system of equations without graphing. And it is set up to where we can do the elimination method. So do we have a common coefficient in front of the x or the y? Okay. Both actually. So it's up to you. Which one would you rather eliminate? Okay, it's up to you. So if I want to eliminate the y's, would I have to add or subtract them? So our classmates said they want to eliminate the y's, so just focus on the y's. They have opposite signs, so would adding or subtracting eliminate the y's? So that's what we'll do. And it's up to you. Sometimes you could choose to do something else and it still work out. Right now, we're deciding to eliminate the Y's. So then if I had to add to do that, I have to add to do the rest. What's 5x plus 5x? What is 29 plus 41? 70, actually. I thought 60 at first in my head too, but yeah. It is 70. What's opposite of multiplying by 10? Whatever you know on one side. So I know that my x will be 7. Let's see if that gives me my final answer already. Maybe there's only one with that. And there is. So it has to be that one. But ordinarily to find my y, I would plug it back into one of the originals. It doesn't matter which one. So I'm just going to pick the top one. And when I do that and start isolating the y, 5 times 7 is 35. I would subtract 35 on each side. I get 2y equals -6. Dividing 2 on each side, that's how I get that y equals -6. But if it's multiple choice and only one choice has the correct x, then that makes it easier. All right, any other ones? If it's quick, we might fit it in. Me?
Question 5 for part 2.
Oh. Part 2, number 5. Okay. Okay, so we're solving each, and they did not specify it looks like they want you to use substitution. But it didn't specify, so you can use whatever method you want. You could type these both into decimals and see where the answer. But if I'm doing substitution, and this one would be easy to do substitution, because this one's almost already fully isolated, then I'd probably start with isolating the x in this one. And doing 84 divided by 7 is 12. So I know for this top one, the x is 12. Let's see if that narrows it down. And it does. But ordinarily, I plug it back in, solve for y. In this one, I would isolate the top equation because it's already almost fully isolated. And I think I'd rather isolate the x because that looks easier. When I do that, I get that x equals -4y. So notice I don't get that x is just one number this time. I get that x is an expression. And so I have to plug in that expression into the other for the x. So I get 4 times -4y plus 27y equals 11, and I have to start simplifying. I get -16y plus 27y equals 11. And I'm out of time, but hopefully that helps me. I'll keep solving it. This one is a substitution is probably what they were trying to get you to do. Once I kept solving, I got that y is 1, which helps narrow me down to that answer. Okay. Bye, have a good day.